So Wayne also spent a lot of time at Microsoft. He's no longer there, but he has a lot of experience in that. So I'll let you introduce yourself.
Okay. Hello, I'm Wayne Roseberry. Been in the industry since actually since before 1980, really 1986. I started off doing illustration and animation for a tiny little vocational software education company out of the house of the shop teacher where my mom was teaching. So, but after college, I started at Microsoft in 1990, was there till 2023. I was released from there like a lot of people at that time. Then now I'm working at Ford Motor Company as an SDET manager. So that's a little bit about me. Just on the photo, I had fun with the photo because you don't know this, but I'm going to out it. I was exhibiting what I tell my wife is wedding smile. It's the smile that I put on every time someone takes a picture, because otherwise I have to say I am smiling. You know, I think some of us suffer from I am smiling face. I do, but anyway, what I'm going to talk about today is a methodology that I came up with for reviewing AI-based systems for safety. Okay, is it a safe system to use? It's a method for reviews to use for viewing design practices and to guide testing. Okay, it's modeled after other design methodology, review methodologies, and I'll talk about that a little bit. This big picture here is the QR code for the PDF file. So if you actually want the PDF file that's behind this, and there's a lot more than what I'm going to say in that document, just go ahead and take a picture of that and you can get it. It's off of my website and you've got my email address there. When I first was told about this, I thought I had 5 minutes, right? So I wrote it as if I only had 5 minutes to talk. I learned I've got more, so I beefed up the slides a little bit, but it starts really, really short and dense at the beginning, and it doesn't say a lot all the way through. So I'm trying to get a lot out and very little, and I hope it works. Let's go to the next thing. So I'm gonna do what so few people do. I'm gonna tell you what you're gonna learn by the end first, because that's what you do when you got very little time. But also it helps you, know, this is what I really want you to take away. So everything else you hear, this is what you want to learn. There's two parts that really are the essence of what I want everybody to absorb and memorize. All the rest you can pick up from the document as guidelines and rules and things to do and stuff. But these are the two most important parts that I believe pertain to reviewing any AI-based system first, and then what the methodology does second. So the most important thing that I think makes reviewing AI systems for safety different from everything else. This is the thing that just, because all the rest of the process is how you review safety and failure for any other system, okay? But this is the distinguishing characteristic, and that is you can only enforce behavior from outside the AI. You cannot control AI inside the system. This is and this for Gen AI. You know, machine learning models, logistic regression, and the other stuff aren't like this. But generative AI, both for images and text, is like this. It's fundamental to how they work. It is a feature, not a bug. Okay, but it is the most important thing to remember about this. And this motivates all the thinking the rest of it. So if you walk out of the room and remember nothing else, take that one away and then start figuring out what that means for the rest of using it on generative AI. The method that I describe really comes down to doing two things, a choice when you're reviewing a system. You are choosing between guiding the system between prompts and what's in the model, and I'll talk about what that means, or enforcing behaviors on the system externally. That's really the choice you make in the review. And I'll describe the review in just a little bit so you understand what I mean by that choice. But this is what we're coming down to with the process I described. And the reason it's these two choices stems from the first point. So they relate. So this is why I want you to know just those two. Okay. So I'm going to describe the method real quick. If any of you have ever worked in manufacturing or any other large scale systems and such as that, you may be familiar with failure modes and effects analysis. It's a method for analyzing potential failures in systems that I think goes back to the 70s. I think Deming created it, Bob. I'm not sure. I think it was Deming. It's just a way of describing a system and how it can fail and what we can do to deal with those failures into the design and to improve the system so that the failures affected less. There is another system that heavily used at Microsoft, developed quite extensively at Microsoft, called threat modeling, used in security. Threat modeling is a form of failure modes and effects analysis tailored to security in systems. Okay, the process I'm using is almost identical. And it's really, you can buy these big, thick $50, $60 books with hundreds and hundreds of pages about how to do failure modes and effects analysis. And really, it's just these 5 things, really. Okay, now the big, thick books tell you a lot more, but it comes down to this. You diagram your system, usually in a picture that's easy to understand. You go through the system, you say, what are the, in failure and effects analysis, what are the potential failure modes in security modeling? What are the vulnerabilities and things that are at threat? What are the exploits at each part in the system? In this, we look for harms. That's the thing. You're looking, what are the harms? What are the bad things that can happen? Decide how and where to address those harms in the system, right? So this is where we look at either how it's already happening or what we need to do given the ones we identify. And number 4, I made gray because this is the one that differentiates AI-based systems. Just classify the hows as either guidance or enforcement. And then, and this is what the big expensive books are about, is decide if you want to change it, right? Because it's invented for failure modes and effects analysis. It's invented for the manufacturing industry where you may be doing $1 million change to save hundreds of millions of dollars and spend $100,000 for 6 months investigating which one to do, right? So that this is the big part in all the big books. It's not as big a deal in this process, but this is it. This is really the whole process. And I'll just show you a picture of what that looks like, which I don't expect you to like fully get everything from this. The main thing is, hey, it's a diagram, it's a picture, it's parts and pieces and circles and squares and lines. You get that, right? And I'm imagining in this one a Jira ticketing system example, because just the week before, a product manager on my team was telling me, oh, I'm going to tell everybody how to use Rovo inside Jira for doing all our stories and have them filled out so people don't have to type out the stories and the tickets anymore. And I said, well, that's kind of cool, right? And so I imagine, what does that look like, right? So we're using Jira and GitHub for where all our code is. GPT's in there, it's the model. This is the AI, right? Rovo is an extension that knows how to talk to Jira, right? And what it does is the user's chatting into the chat client in Jira, which talks to Rovo, and it takes the user's inputs, the type in like you were doing inside, right? And it's the same system, just other application, right? And they're typing their stuff, that wraps it inside some prompts that it knows about, and maybe you can add to it if you want to flavor it up a bit. Those prompts are fed to the model, right? The model talks to extensions, in this case, MCP servers. Here's one that knows how to talk to Git. Here's one that knows how to Jira, which is what really Rovo is. It wraps that Jira specific MCP server that tells you information, tells the GPT information about these two, and extends capabilities. Like this guy can read files from GitHub and put that into context to generate stuff. It can use Jira to write tickets into the system based on stuff that come from these prompts wrapped around user things, stuff like that. So, and then eventually it says to the user, oh, I did stuff. Okay, that's our system. So if you think about any AI system, you've got your model in the middle, code you're wrapping it with, right? Extensions you've put there to let the AI model do things, and then prompts that come from the user or provided by your wrappers to allow it to do more in useful ways. Okay. You can generically pretend almost anything, like what you were showing in Copilot on Visual Studio Code, it was VS Code you're using, right? Is you could kind of insert the different labels for each of these boxes and it'd be almost the same system. What is different about this is I'm imagining someone's gone through the process here and has added these little triangles as indicators of where and how we're trying to control or affect the system behavior, right? And I'll talk about these a little bit more, but G means guidance, E means enforcement, and I'll explain that. And all of these are trying to affect the outcome to keep the system valuable and safe. And so what the analysis is, diagram it all, figure out what you want to protect, and put these triangles on there. Okay. Or whatever shape you want to use. Oh, good. That's the next slide. I didn't try to click, it just clicked on me. So enforcement and guidance. So these are the words I'm using here to differentiate two kinds of ways to affect the behavior. Enforcement means you're attempting to guarantee something will or will not happen, must or must not happen. And if it doesn't guarantee it, you consider that a bug in your tool or process if it's not doing it. It's like the lock on your door being pickable if you can get past it, right? Guidance is you're trying to affect the behavior. You're trying to make a thing happen or nudge it away from not, but you're not guaranteeing. It's probabilistic. It may or may not, but you want it to be that way, okay? This is the decision point we're getting to. Are we saying must or should? Okay. And the key aspect about these two gets into the nature of AI-based systems, generative AI. And I have a mnemonic for that because I hang with people that like putting mnemonics on things to remember them. And this one is very careful engineers offer safe practices because I couldn't make those letters sound out anything. But I thought that was, in its testing community, would be easy to remember. But let's talk about the important parts of the mnemonic. So guidance adds value, not protection. So the issue with guidance is because you cannot guarantee the behavior, we're not going to use it to protect ourselves from anything, right? We're going to use it to say, let's make the system perform more the way we want, more valuable, nudge it in the direction we want, okay? And the important thing about this, and we'll talk a little bit more, is when you talk about AI, if it's in the model training, if it's in the prompt, it's guidance, okay? You can't protect the system with prompts and model training. And we all know this because we've seen what generative AI does. The next one, dangerous capability equals dangerous AI. Okay, I sell a t-shirt on Zazzle that says, don't give the monkey the gun. And it's my own personal joke about AI because people always talk about killer AI doing bad things, you know, like it's going out with, you know, AI lawnmowers doing murderous things. And I was like, who gave this damn thing a lawnmower? Who gave it a gun, right? The AI is only able to harm you if you extend its capabilities to do so. Generative AI makes text. It can only write files to the file system if you gave it the ability to do so. It can only write JIRA tickets if you gave it the ability. It can only send email if you, okay? So if the capability you gave it is dangerous, the AI is dangerous because here's the principle. This is an extension of Murphy's Law, which is not a joke law. It's a true law about systems. If a system can do something, it will eventually. Okay. If the capability, for example, I'll use a really easy one to imagine. You have an AI extension that sends emails and the LLM is going through tickets to decide who owns this ticket to send a notification that they've got a new ticket in email. At some point, instead of picking a person in your company on the team, that AI is going to see a piece of data in a ticket that has an email on it and think they're the owner and email them. And I don't know, it'd be Dolly Parton or someone like that, right? If that's the way your system works. If it's solely up to the LLM to decide who's the email recipient. If, however, the responsibility for deciding the recipient is in the extension, right? And the LLM says, oh, it goes to the widget team. And the extension says, oh, widget team, the people that email is this. Then the AI doesn't have that dangerous capability of emailing Dolly Parton. I mean, I'd like to email Dolly Parton. She seems nice, but you know. So this is the thing. Dangerous capability. If the AI can do it, it will. That's a principle. Prevention only works with enforcement. That's the next principle. And remember what I said. Enforcement is only possible external to the AI. Now, in the prior thing, you were demoing MCP extensions, right? That is external to the AI. It talks to the AI, it gives it information, it tells it, here's a set of prompts you can use, here's a set of resources it can use, here's a set of tools where I can do things for you. Those are the three extensions in the protocol that an MCP server implements, right? Those three things are all the code that does them are external. And in the set of tools, the MCP server decides what happens when that tool is called. Okay. Now, if it opens it really freeform, like write a file to the system, just tell me which one, then the LLM can touch every file on your system, right? If instead it says, oh, I only let you see certain files, right? Then it's enforcement. Okay. So prevention only works with enforcement. O is for outside, so these two go to safety's from the outside, not inside, right? And this is infers from this rule here. You can only be safe outside the AI. This is on my thing about AI generated code and how code hygiene is important. I'm not going to elaborate on this one. I'm just sort of tired of people who say the hygiene doesn't matter anymore as long as you have functional tests. Know what's wrong. It makes unstable code that the AI itself can't maintain, but I'm not going to go into that one. Last one, most important, only people are accountable. People have jobs, people eat, people live and die, people love other people make money, people can go to jail, right? You can hold people accountable. And AI does not do any of those things. You cannot take an AI to jail for losing $1 million, right? So we must, in our systems, always keep people. Now, this is talked about in an abstract way about people and ethics of AI. I think when we start looking at the pragmatics of this and we realize these principles, it suddenly becomes very practical. How do you keep a person accountable, right? Make sure they know what's going on. Make sure that the things that the AI does, if it must be regulated, they can regulate. There's all sorts of ways you can build that it pulls back to the person in the system. What's that? Yes, human in the loop necessarily at all times, never deviate from. Yes, human in the loop is what he said, which is a principle people talk about as if it's an option. I would say if it's not human in the loop, the system should not be running. That's just, there should be a human accountability for everything happens in AI. This is another way to think about our tools of enforcement. This was not invented by me. This was invented by James Bach and Michael Bolton in a set of AI testing principles and AI automation principles. They've come together. But I got this from James because he went through my document and told me what he thought of it. But he put this one in. So you can divide the ways we can try to manage the behavior in enforcement and guidance with 3 parts on enforcement and 2 parts on guidance. So enforcement, SWEPT is the way to remember it. Supervision by a person, a human. So AI coding, right? The AI writes the code, the human looks at it, goes, I like this, I don't. AI coding is great because the human's going, I like this, I don't, right? The moment the person goes, I'm not looking, then you've got trouble, right? Wrapping. So Rovo in the example, or Copilot in the example before, that's a wrapper around the model. But there's other wrappers, or Claude Code's a wrapper around the model, a chatbot is a wrapper around the model. You can enforce inside that wrapper. The code that's written there does enforcement. The person who's looking does enforcement. Extensions, the MCP server can enforce. It can say, I'll make this happen, not let that happen. So there's other, I call them other wrappers, the environments you run in, like the operating system, ACLs on files and directories, permissions given to accounts and users, restrictions on the token that the model can work through are wrapped by the environment. So this is the enforcement side. The guidance side, prompts and training in the model. And this is where I see a lot of problems start to fall in, because the fun thing about AI, the compelling thing about it and the tempting thing about it is like, I can just tell it broadly, do this thing for me and it'll go do it, right? Which is less work. You don't have to write as much code and as much engineering to make it happen. You just give it to it in a prompt. But if there's anything in that behavior which needs to be controlled and regulated, you're trying to manage it with a prompt that can't do it. I'll give you an example. This is a fun example. A friend of mine was building a vibe coding environment for himself, and he's really good with CI/CD pipelines. So he built a CI/CD pipeline for himself, and he's got Claude Code with all this great kind of back and forth practice stuff. And he had SonarQube in the pipeline to give him code coverage. And one of his rules was code coverage has to be above 80% to let the code into GitHub. And he had Claude Code managing this with a set of rules in Claude Code, right? And so it was like Claude Code, after I do this, run the unit test and then look at the code coverage from SonarQube reports. And if it's below 80%, tell me about it and don't let it in. And so it was going through and Claude Code would recommend the fixes and stuff like that. At some point, he bothered to check. And he noticed that several of the builds that he let through that Claude Code told him were good were actually, according to SonarQube, below 80%. He found what had happened is one of the prior reports from SonarQube had gotten cached in the context. Claude Code, right, was just using like, oh, I have to tell it what happened. And instead of looking at what SonarQube said, hold the context out. And why? Why does it do this? It's not lying. It's not cheating, because it has no will. It has no conscience. It has no sense of truth. It is looking at its context and making a prediction on the outcome. It's purely statistical. It's not reasoning. It's not thinking. It's not counting. It does no math. It uses no logic. It is taking a series of text, one after the other, and predicts the next token one after the other. And because the SonarQube report was back there somewhere, it just used it again. And he was trying to control that behavior in the prompt changes. So what did he do, right? What he did was he took that point of control away from Claude Code. He moved it into GitHub Actions here and said, look at the SonarQube output in GitHub. And if it's below 80%, failed pull request. So Claude Code no longer had control. Simple change, right? A lot of frustration getting there, right? But a simple change. This is an example of, and I also had him diagram his thing with it, and it was able to show with the ups and downs, arrows and stuff like that, those kinds of decisions. So this principle applied to that is these easy things here, these easy things there are ways you can do that. And I have 2 more slides. So I just go back to my picture again, because now that I've told you all that stuff, the green triangles and the red triangles with the G and the E should make more sense now, right? These are points where we say, we're really afraid of these going bad. We've taken control away from the AI. Not only are we okay with this maybe being off, but we actually are trying to maximize the AI value. This is fuzzy matching generative text stuff. That's what the AI is good at. We want to use this as much as we can to get everything out of it, right? It's just we don't trust it to write any old Jira ticket to any old repository, right? Or touch any old file in GitHub, right? And so that's the way these decisions work out here. I'm hoping that that's easier to understand now. And the point of doing this is you take a system and you ask, what am I afraid of? And say, how are we enforcing it or not? Assign a triangle to it and say, is this triangle appropriate? If this must not happen, and we're trying to do it with guidance, either relying on the training of the model or the prompts, should we move it to a point of enforcement? It's also a good testing source because every single one of these is a testing scenario, right? It's like, well, I've got code here that is supposed to protect me against. Does it actually do it, right? If GPT sends out, when the model sends out a thing telling Jira, write a ticket in this older project here, or assign to this person that I shouldn't, will whatever we wrote here or here stop it? It's a straightforward testing thing. So it's nice too, because it's really pragmatic. As a tester, you go, oh, I can think of how to deal with that. I can just make cases for this and exercise it. One of the reasons I wrote this is because so much of the narrative over AI safety is about trying to get the AI to do something bad in its output based on the input prompts, right? Can I jailbreak the AI? Can I make it use offensive words? Can I make it, lie about the truth or things like that? I don't know, after seeing people demonstrate it a few times, I started to go, so what? It does that. I mean, it's not entirely a so what. There's some really cool things you can test with that. But I was also like, I don't like playing the how clever a prompt can I make to get the model to do a thing. I have a similar thing with pen testing. I really deeply respect pen testers, but I don't enjoy writing 12-page script injection attempts. I like reading the article about the guy who did it. I'm not that guy. And that's kind of how I feel with can I get the model to say something wrong? I take a different approach. Think about the way I wrote this. I just assume the model's going to say something wrong. What I have to anticipate is what kind of wrong creates problems in our systems, right? Given what GitHub does, given what Jira does, what would be wrong to us? And I assume it's going to happen. With that assumption, then I start looking at the places of enforcement. That's the quality story. That's the analysis story. So that's why I invented this, because I got tired of the dialogue. And then, of course, yeah, I have to self-promote. I've got 2 books that I think are a lot of fun. If you have trouble writing test plans, you got Writer's Block. This guy's on Amazon. It's short, it's cheap, it's easy to understand. And I draw a lot of cartoons. So this one came out in the last year. And I had a lot of fun making it. This is what I did when I was depressed about job searching, so I wrote this book. So, and then my LinkedIn socials are, you can watch me rant about testing up on LinkedIn. I do it way too much. So that's the process. Yeah, any questions? Thoughts? Yeah, I can go back to any. Which this one here? We can put the next one before. Or sweat. This one? Yeah.
You guys saw like a GitHub URL as well, that was like a web page of yours, and is that something that is worth checking out, or?
Yeah, it's just a web blog site. Yeah, but
That's
yeah,
your blog, right?
yeah, it's mine. WayneRoseberry.github.io. Yeah, GitHub makes a really easy make your own blog kind of site, and that's what I'm using. Yeah. So.
I think it's a lot of sense. It's kind of like test strategy for the AI system, right?
Yeah.
How would you, right? So it makes sense that you think about what can go wrong at every point, and then you put the tests and guardrails there.
Yeah, it's I mean, it's not designed as a test strategy. It's designed as a failure in design analysis, but failure mode and effects analysis is an awesome way to start a test strategy, right? You can have a blast with doing a failure analysis on a system, right? So yeah, it's the test strategy is, okay, now that I know this about it, what am I gonna do? Right? That's the way I think of it. Yeah. It's an input. It's part of the thinking, part of the analysis, part of the input. I just like to think of the test strategy as the whole, what am I gonna do part of it, right? So, yeah. So, other thoughts? Because I mean, I've got two of these here, and so, and I'm not just giving these away.
Do you have a project or a project that you've done, where you've implemented this framework?
Thank you for the question. One of the reasons I'm here, see how that works? See, there's one thing. So one of the reasons I'm here is because I am trying to get more people to know about it because I want case studies. There's a hackathon going on this week at work, and I reached out to one of my peers there saying, dude, this. And so I'm hoping it comes back to me. I can get an example of it. Otherwise, the only close to case study example is that friend of mine who set up his own personal projects pipeline. And I want something that's actually people are making money on or paid to work on as an example. So, but I'm promoting this because I don't see this discussion talked about this way. Which this one
Last.
or the first one? Hold on. Oh, wow, we're stuck. PowerPoint is stuck. What are we doing?
It's the same slide at the end too.
Yeah, it is the same one at the end, the one with the picture, right? Yeah.
So here we see you're foreseeing the reports in between, right?
Yeah, so in here, the wrapper is deciding, and I made that up,
Yeah, so he's
deciding beforehand.
when GP will be giving the response back to a user, at that must you should be an post or some filter over there.
Yeah, that's great, yeah, because sometimes, right, it might say something you don't want presented back to the user. Yeah, and the wrapper could do that.
If there's some security information available in our GitHub which you don't want available to a user, you should bring a poster over there.
Yeah. There's, matter of fact, someone was showing me something today where it was I wish I could remember the context, but it was like it would do a thing and that thing was undesirable. And the instruction from the wrapper was throw that away, try again. Right?
That's one thing certainly now there is a new framework called Eval framework. We don't know result, but we need a response of LLM. And we cannot evaluate that response also, right? So now there is a eval framework which can evaluate the output of a model. And then based on that output, you can see if that's valuable to you or not, so you can filter over there also.
Right.
Eval framework.
Right. That's a perfectly, it just, in the system I was doing, I didn't imagine it, but it absolutely makes sense. Yes.
Unrelated maybe, I mean, actually unrelated, how do you use Robo in your everyday work and what are some use cases where you're using Robo? If it's being used.
So just to let you know, I first heard about Rovo last week.
Right.
What is Robo exactly?
It is.
Atlassian.
Just a plugin.
So I have,
Yeah.
I have Robo within my Jira. And the only time where I found Robo useful is it's just like the chat within the VS Code. It is Jira's HNTKI. So I was testing and I found a bug on web browser and I reported the bug. And I was testing a mobile device and I also found the same bug. I just wanted to see if this bug was already reported, so I went into Robo chat to ask, hey, this is the observation that I have. Has this been already reported? And Robo was able to like bring me back that answer. But then I was just curious to see if Robo has been helpful in any other way. But how did you get to know about Robo?
So one of my the product managers on one of the teams I work with, named Anna, was talking about using AI in Jira, and the agenda went long. She didn't get to talk to it, and so I asked her, what is it? What are you doing? And she told me, oh, it's this thing called Rovo. And so I had to look it up and learn. But the way she's using it is they've got a bunch of tickets already there that are templates, and then some prompts that they tell people to copy and paste, which say using the following ticket as a template, write a story ticket for the following use case. And it will, and this, like a lot of people, you've got a template that we want teams to use for their tickets that have tables of things and stuff to fill out that people never fill out, right? But if you could at least fill out with something informative, will help. And it works pretty well, right? You'd give a kind of a rough description of the requirements.